Hey guys, welcome back. This is Mr. Kim, and I am going to go over the AP Chemistry 2025 FRQ question number 5. Complete Lewis diagrams and some physical properties for compound X and Y are given. Based on the Vesper theory, predict the geometry around the silicon atom in compound Y. All right, so this is kind of easy because if you take a look, this is silicon right here. And as you remember from the previous question where we talked about hybridization, the orbital hybridization of the silicon is going to be an sp3. Why is that? Because silicon has 4 connections or 4 bonds, and it has no non-bonding lone pairs. So therefore, the total is 4. So it's going to be S1P3 for a total of SP3 or a total of 4, right? So what do we know about that? Maybe some of you memorized that SP3 has a tetrahedral shape. Um, some of you didn't. But the other thing is you don't really need to know that because you know that when there are 4 electron domains, right? We got 4 right here. You put them into 3-dimensional space, we know that they'll form a tetrahedral shape or tetrahedron. So the answer to this one would be tetrahedral or tetrahedron. This is adjective and tetrahedron would be the noun. They did say predict the geometry, so the adjective, I guess, works. Part B, student claims that compound Y has a higher boiling point than that of compound X because compound Y has stronger London dispersion forces. Do you agree or disagree? All right, so if you take a look at this, what do we know? We notice that essentially the two are exactly the same, except what's going on. Silicon has a larger radii, doesn't it, right? Silicon is lower than carbon, if you remember, right? Because they're in the same family, but silicon is lower than carbon, so it has a bigger atomic radii or more shells, right? So between these two compounds, you'll notice that this one has larger, more electrons um, that can be polarizable, right? Um, so therefore, we would say that if you have more electrons, then they are more polarizable, and therefore you would say you would agree, right? Silicon has more numbers of electrons, right? And what else? And in more shells, right? Thus, also having a what? If you have more shells, right? Larger atomic radii, right? This allows more polarizable electrons. Thus, compound Y would exhibit a stronger London dispersion force. Okay, let's move on. Next, an equimolar mixture of 2 compounds is heated. When the mixture reaches 82 degrees Celsius, which compound will have a higher vapor pressure? Justify your answer. All right, so what do we know about this? This one's actually not too bad, right? So we mix the two and then we heat them and it reaches 82. So we understand that at 82, we have reached the boiling point of X, but we have not reached the boiling point of Y, right? So we would expect compound X to be vaporized more, right? So it would be found more in a vaporized state, right? So we would say compound X will have a higher vapor pressure at 82 degrees Celsius, right? At 82 degrees Celsius, right? We will meet the boiling point of compound X, thus vapors of X will form. However, at 82 degrees Celsius, we have not met the boiling point of compound Y. Therefore, we will see less. So we'll see less molecules. Oh, actually, that's not true. It wouldn't be less, right? We wouldn't see any. Yeah, my apologies. My dog was going off, right? If you can tell, that's probably in there, right? Um, so I had to go silence them. Okay, we'll see no vapors of Y. And that should be enough. Okay, let's finish this question. Part D, the mixture is heated to 198 degrees Celsius in a sealed, rigid 12.5 liter container, at which point both substances are gases and the total pressure in the container is 2.30 APChem. Calculate the number of moles of gas particles in the container. Again, this one is a lot easier than you thought, because originally I was thinking maybe they're asking for partial pressure, but that's not even what they're asking, right? So what do we got going here? So let's start labeling some things, right? This is our temperature, and we got volume, and what else? We got pressure, right? So, oh, sorry about that. Pressure, right? So what do we got? If we have that, what do we know? We know that this looks a lot like Pivnert, right? And which it is. So let's go and start putting some of that stuff down. So they want to figure out the total number of moles of gas, right? That would be N, right? So I'll say here N is equal to, right, like that. And let's put some information down. We got Piv nert, right? So what do we got? Pressure is 2.30 APM. Volume is what? Is 12.5 liters. N is what we're trying to solve for. What is R? 0.0821 or 06? I forget. Liters, atmospheres over mole kelvins, right? Right, and we got a temperature of 198 degrees Celsius. And we know that that's going to be converted to kelvins. And let's just go ahead and do that in my shopping list. So that's going to be 471 kelvins, right? Is that right? 273 per 8, 9, 10, 11. Yes, that's correct. All right, so now we set it up. So to set this up, it's Pivnert, right? And we know that we're solving for N, which is going to be PV over RT. And let's just plug our values in and we will take it home. 2.3 ATM times, what is our volume? Volume is 12.5 liters, all divided by 0.08206 liters atmospheres over mole K times 471 kelvins, right? Canceling out, we get 1 over mole, which is mole, right? And our answer comes out to how many sig figs? We are using 3 sig figs, right? So it's going to be 0.744 AT. No, not ATM moles. Sorry about that. It's going to be 0.744 moles. Okay, and that's it. That they want the total number of moles. It's not even partial pressure, is it? Right? And that is our answer. Now, had they asked for the partial pressures of the two, right? Then that would have been also easy because we know in part C it was an equimolar mixture, so we would know that the number of moles is identical, in which case each of them would have been half of that, which would have been, what is that, 0.372 moles each. But that's not the case because they asked for a total number of moles. Okay, so that concludes question number 5. I'm sorry about the distraction by the puppies, and I hope this helped someone. Thank you for watching.